Hi everybody, today's topic is approximating with powers of 10 and multiplying and dividing in the scientific notation. You do not need to write everything down in this video, but be sure to jot down important information and at least one example of each type of problem that we'll cover. Remember that you can also pause to jot down important notes, rewind to review information again, and fast forward if you think you got it. Just be careful. You don't want to fast forward so much that you miss out on something important. Let's begin. There's a lot of science connections here with the metric system. So with approximating with powers of 10, we are using the multiples of 10 to make estimations of really, really big numbers, like in the millions and billions, or really, really small numbers, like if we were looking through a microscope at a very small culture of bacteria or something like that. So right here is an important table of the powers of 10 that you will want to pause the video and jot down. So with the power of 10 to the 9th power, we have 9 decimal places. That's like 10 multiplied by itself 9 times and 1. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9 decimal places. Usually we use a prefix of giga, like gigahertz when we are measuring something with electricity. 10 to the 6th power has 10 multiplied by itself 6 times and 1. And it has 6 decimal places, or 6 zeros at the end. That's usually mega as the prefix. Megahertz, megavolts. 10 to the 3rd power has 3 decimal places, or 3 zeros, and that's kilo. So we have kilograms, kilometers or kilometers. 10 to the negative 3rd power, it has 3 decimal places. So it has only 2 zeros in there because that 1 counts as a decimal place. So we've moved it over 1, 2, and 3. So that 1 counts as a decimal place. For the really big numbers, we can just count the zeros, but the numbers less than 1 in the decimals, it's the decimal places, and the zeros will be off by 1 because the non-zero digit will count as a decimal place. So 10 to the negative 3rd power will be 1 times 1/10, because we talked about negative exponents in our last video. 1 times 1/10 3 times. So that's a millimeter, millisecond, milligrams. Those are starting to go in the negative exponent regions. 10 to the negative 6th power has 5 of those zeros and the 1 as your non-zero digit, and that's a microsecond. 10 to the negative 9th power, 9 decimal places, or 8 zeros. Those are nanoseconds. Negative 12th power is 12 decimal places, and those are picos now. So they're getting super tiny. So exponents are used a lot by scientists to measure really big amounts like the world population, and really small amounts like measuring a really tiny bacteria or virus. So how are you going to use powers of 10 to approximate? I'm going to give you some examples. If I were to write a number like 1,000, I would know that it is 10 multiplied by itself 3 times. So instead of writing 1,000, I can just write 10 to the 3rd power. It's 3 place values to the right. And like we said before, 10 to the negative 3rd power, a tiny amount. Instead of writing 0.001, we can write 10 to the negative 3rd power, and that would communicate the same thing. In your exercises, you will be asked to approximate using those powers of 10. So let's review how to approximate values also known as rounding values. So here's a review of rounding rules. You just need to look at the neighboring number and decide if it is 4 or less, you would let it rest. And if it's 5 or more, you would let it soar. So letting it rest would mean that you're keeping that digit the same. Letting it soar would mean that you would go up 1 digit. So you would be rounding up. So as an example, if we have 47,000 kilometers using a power of 10, how would we approximate that? Well, we would look at the neighbor number 7. So it's usually the neighbor number would be 1 less than the highest place value, so that would be 7. Is it 4 or less or 5 or more? You should have responded with it's 5 or more because 7 is greater than 5. So 4 or less would be like numbers like 0, 1, 2, or 3 or 4. 5, 6, 7, 8, and 9 would be the 5 or more. So this is a 7, it's 5 or more. So we would now round. Instead of 47,000, we would round it to 50,000. So we are bumping up the 4 to a 5. We're letting it soar. So now we can say that 50,000 is the same as 5 times 10,000. So we can change this to 5 times 10 to the 4th power. All right, next up, with multiplying and dividing numbers in scientific notation, we first have to review multiplying and dividing exponent rules. When you have a problem like 3 to the 8th power times 3 to the 4th power, you should remember that when you expand it all out, you just have 8 3's being multiplied together times 4 3's. So in total, you have 12 3's being multiplied together. So the shortcut is to add those powers together, keeping the base number. When you multiply exponents with the same base, keep the base and just add the powers. This will come back to us later when we are working with scientific notation. With dividing base numbers that are the same, you are expanding it all out. So a to the 7th power divided by a, and without a power, we can assume that it's just a to the 1st power. We have one set of a's that we would cancel out. So essentially, it's just subtracting. Top power minus the bottom power. So 7 minus 1, which is 6. When you divide exponents with the same base, keep the base and just subtract the powers. Order matters, top minus bottom. So when we are dealing with multiplying and dividing in scientific notation, we have to remember those rules. It's quite similar to it with a little bit of a change. The two things you need to remember is that you are using normal multiplication and division for the first part of the scientific notation, and for the second part, you are using multiplying and dividing exponent rules. So here's an example of multiplication with scientific notation. We have 2.1 times 10 to the 2nd power multiplied by 3 times 10 to the 3rd power. So what we mean by the first part is the first part of each scientific notation component. So we mean the 2.1 and the 3. You're using normal multiplication or division. Here it's multiplication. That's between the two scientific notation parts. So the first part we would just take 2.1 and multiply it by 3. The second part we would use the multiplying exponents rule. They have the same base of 10, so we would add the two powers, 2 plus 3. So we end up with 2.1 times 3 to get the 6.3 times 10 to the 2nd power times 10 to the 3rd power. That means we add the 2 and the 3 and we get 10 to the 5th power. When we write this scientific notation out in standard form, we would move it over 5 decimal places. So originally the decimal place was between the 6 and 3, so we move it over 1, 2, 3, 4, 5. And that's how we end up with 6.3 times 10 to the 5th power, or 630,000. You're using two different rules for the two different components. The first part of the scientific notation follows one rule, the second part follows a different rule. Here's an example of dividing in scientific notation. And in this problem, the numerator is written in standard form, the denominator is written in scientific notation. This problem looks pretty complicated, but you can actually solve it without using a calculator, and we'll show you how. My first step is I'm going to change the numerator, 180, into scientific notation, because then I can use my shortcuts. So I've changed 180 into 18 times 10 to the first power to get to 180. 10 to the first power is just a 10. 18 times 10 is 180. I'm keeping 9 times 10 to the negative fifth power on the bottom. Then I can use my shortcut. I know based on my shortcut that my normal numbers, the first part, is just going to follow normal rules. 18 divided by 9 is 2, because 9 is half of 18. My second part is my exponents, so I have to follow my exponent rules. This is division, which means that I can just subtract the powers, top minus bottom. So it will become 1 minus negative 5. And I know that my two negatives will become a plus, so it becomes a really easy math problem. It becomes 2 times 10 to the 1 plus 5 power, which is then 2 times 10 to the 6th power. And 2 times 10 to the 6th power is really the same as 2 with 6 zeros at the end. There's 3 zeros and 6 zeros, so it's 2 million. It looks like a really difficult problem, but it actually wasn't that bad. Once you change it into your scientific notation, you're good to go. Normal division, just a subtraction here because of the exponents. So that's multiplication and division using scientific notation. Looks harder than it actually is. Let's take a look at some examples now. Here's an example of approximating with powers of 10. It says Liam's mass is 102.1 kilograms. Choose the best estimation or approximation of Liam's mass. Choose one answer. Go ahead and pause the video and see if you can try it on your own first. All right, so we have Liam's number, 102.1. We can round it. We can either keep it at 100 or we could round it up to 200. Which one do we think is better? If you said 100, you are correct. It's not quite big enough to round up to 200. So we're keeping it at 100 because we were looking at the 0 here. 0 was 4 or less, so we're going to let it rest. So we're going to approximate at 100 kilograms. Now we just need to write it in scientific notation. So I am going to get a different color and I'm going to see after my 1 how many decimal places there are. 1 and 2. So this becomes 1 times 10 to the 2nd power, 4 kilograms. That would be B. If it were 1 times 10 to the 1st power, it would just be 1 times 10, which is 10. This right here is 1 times 100, which is 100. Okay? So this one is way too small. This one is 100. 100 has 2 zeros. For the second one, Earth has an estimated mass of, I don't even know how to read that number. That is way too big, but that makes a lot of sense, right? Because the Earth weighs a lot, so it's going to have a huge mass. So we're going to use these two answers to pick the best approximation. It should bump up to 6 because 9 is 5 or more, so we're going to let it soar. So it becomes 6 and all these zeros. I'm just going to go dot, dot, dot. So we need to count how many of those zeros there are. Each of these commas are going to count for 3. So it's groups of 3. 3, 6, 9, 12, 15, 18, 18 plus 3 is 21, and 24. So there's 24 of those place values because there's 1, 2, 3, 4, 5, 6, 7, 8. 8 groups of 3 zeros. 8 times 3, 24. So it should be 6, that's the number in the front, times 10 to the 24th power, because there's 24 place values here. So that's our answer, 6 times 10 to the 24th power. Okay, so for this problem here, it says approximately how many times as large is the Earth's mass as Liam's mass? So Liam's mass was, let's see, 100. So that's 1 times 10 to the second power. And the Earth's mass was 6 times 10 to the 24th power. So we got to divide these. We know that division of the same base number is just subtracting. So it's going to be 24 minus 2, which is 22. So that would be 6 times 10 to the 22nd power. 6 divided by 1 is that 6, and then the exponents with the same base divided is the same as subtracting. So 6 times 10 to the 22nd power. Those are our answers. Great. Okay, here is an example of multiplying and dividing in scientific notation. In this problem, they want you to calculate the product and give your answer in scientific notation. They also gave you a calculator for you to calculate your multiplication or division. Go ahead and pause the video and see if you can try it on your own first. Okay, let's try this out. I know this is multiplication and it has scientific notation, so I'm going to color code this first part. That's going to be using my normal exponent rules, and this second part I am going to be using my exponent rules. So for the first part, I'm using normal multiplication. It's going to be 8.2 times 2. And then the second part, I'm going to be using my exponent rules for multiplication. Exponent rules tell me that I need to add these powers. So it's going to be -3 plus 2. So 8.2 times 2, I can use my calculator for that. (8.2) times 2, I get 16.4. So that's what I got for the first part, 16.4. My second part, I am using the exponent rules of adding. So -3 plus 2, that means I have 3 negatives and I have 2 positives. Each pair cancels out, so I'm left with 1 negative. So that's 10 to the -1st power. Or I can use my calculator for that. It looks like my answer is in scientific notation, except for one little thing. This number is not between 0 and 10. The first part of your scientific notation number needs to be between 0 and 10. This is 16. So that means I'm going to need to move it back 1, okay? The easiest way for me to do this is to write it in standard notation first. 16.4 times 10 to the -1st power means I need to move it back 1 and to the left. So it's going to be 1.64. That's my actual number. The actual answer is 1.64. How do I write 1.64 as scientific notation? Well, that means it's not really being multiplied by anything. It's being multiplied by 1 to get itself. So anything to the 0 power is 1. Okay, so again, I move this back 1 spot to figure out what the number actually is, and it actually is in scientific notation. So I'm really just putting in times 10 to the 0 power just to put it in scientific notation. So let me do that. Oops. Okay. So that's the only tricky part about these problems. You have to put it in actual scientific notation. If I had kept it at 16, oh, well, it's not even going to let me. But if I had kept it at 16.4 times 10 to the negative first power, it would have said it's not in scientific notation. Let's try another one. Go ahead and pause your video and try this one on your own. All right, this is a division problem. So I am going to first actually change it so that they're both in scientific notation. That'll make my life a little easier. The top stays the same. The bottom needs to be changed to scientific notation. Here's the 2. It got moved over 1, 2, 3 spots. So it's 2 times 10 to the 3rd power. Then I can follow my rules. My normal numbers follow normal division. My exponent numbers follow exponent rules. So this becomes whatever 1.88 divided by 2 is. That's 0.94. So that means that the front number is 0.94. The back number is going to follow exponent rules. So I have 10 to the, this is subtraction top minus bottom, 10 to the whatever that answer is. So it's going to be 0.94 times 10 to the 6 minus 3 is 3rd power. Again, not in scientific notation, because it needs to be a number between 0 and 10. And this is a decimal right now. So it needs to have 1 decimal to the left of that decimal point, 1 digit to the left of it. So I need to change it to 9.4, not 0.94. And let me just review that because I think I said that wrong. It needs to be a number between 1 and 10. My bad. I said 0 and 10. So 0.94 is not between 1 and 10. It's between 0 and 10. I misspoke there. This is between 0 and 10. So we need it to be between 1 and 10. So we need to move it over so that it has just 1 digit in front. Normally we would move this over 3 spots. 1, 2, 3. This answer is supposed to be 940. So if we were to move it so that it's here, we would move it over 2 spots. So this answer is 9.4 times 10 to the 2nd power. Okay, 3 spots over would leave it here. We want to move it just between 9 and 4. So that's only 2 spots. This is 9.4 times 10 to the 2nd power. So that's the answer for this problem. Let me know if you have any questions as you are solving these exercises. I'll be more than happy to help you out. If not, I will see you in class.